What you're hearing is a crowd audio system I built to scale sound as the number of characters grows without blowing up performance or turning into noise. At small sizes, you hear individual characters. As the crowd grows, the system shifts. And at higher densities, additional layers can be introduced, depending on what the crowd needs to communicate. In this demo, I'm using music layers purely for presentation. But in a real game, those layers could be chatter, movement, or any kind of texture that adds scale. Here, you can see how the system moves through its different states. Individual emitters begin to fade out, the group representation takes over, and finally, the sweetener layers fade in on top. So, let's start simple. In this scene, when the crowd is small, every character plays its own individual 3D sound. You can clearly hear where each orb is in space, and each voice stays readable in the mix. This works great up to a point. As the crowd grows, playing a sound on every character becomes inefficient. Here you can see the individual emitters fade out, and the system switches to a group representation. Instead of dozens of voices, the crowd is now represented by just a few spatial emitters: left, center, and right. As the crowd grows even further, additional layers fade in. These are not new sources in space, they are sweeteners. They might add motion, texture, rhythm, or simply help the crowd feel larger or more present. In our case, the sweetener is music. When they come in, and how many you use, is entirely up to the design. To show how this behaves under the hood, let's look at the profiler. When the crowd is small, each orb plays its own sound, so voices scale up naturally until the limit. Once we hit the limit, the system switches to group playback, and from that point on, the voice count stays predictable even as the crowd grows. The system also supports different spatial behaviors. Here I'm switching between emitters that stay fixed in the world and emitters that move relative to the listener. Both use the same crowd logic. The difference is how you want the crowd to be perceived. In some games, you want the sound anchored to the environment. In others, you want it to follow the player more closely. To wrap up, here are a few key controls exposed in the crowd manager. First, I'm adjusting the emitter forward distance. Then the horizontal spread, which controls how wide the crowd is represented left and right. And finally, the position smoothing, which affects how quickly the emitters react to movement. Here I'm also disabling average height. With this off, the emitters follow the listener's full transform, including vertical camera movement, rather than staying locked to an average height. So, next up I'll be sharing a footstep surface painting system. It's focused on authoring audio behavior directly inside Unity in a way that's fast and very visual. Thanks for watching.